Hey guys, this is the start of a new series I'm starting called Data Structures and Algorithms. We're going to be going over some of the knowledge that's needed to solve problems frequently encountered in technical interviews, and we'll be going pretty in-depth in each types of different data structures and algorithms so that ideally coming out of this, you will be well equipped to tackle any variants of these type of problems that companies might throw at you. I also believe that it's important to learn these topics even outside of interview prepping, as it will help us think better like a programmer, which can make us better developers overall, as well as give us additional tools to tackle problems you may encounter in your day-to-day life as a programmer. So to be honest, there's a lot to cover in data structures and algorithms, and I predict there's going to be a lot of videos in this series as time goes on. So if you like what you see here, please subscribe to my channel to get future videos, as well as like this video to let me know this type of things interest you. So first of all, this course will be taught mainly in JavaScript, but I will also be providing TypeScript counterparts. In the screen, you'll see examples of the FizzBuzz problem provided in the two languages. And if you look closely, the only difference for this problem between the JavaScript and the TypeScript is the first line, where the argument n is typed as a number and the output of the function is typed as void because it doesn't return anything. A lot of the examples as we go over in this series, you'll see that there won't be too much deviations from JavaScript and TypeScript like here. So if you're still new to TypeScript, I recommend you give it a try. I'll be giving the definitions of the topic that we're covering. Today, we'll be covering singly linked lists, which is a problem that appears frequently in LeetCode, as well as a lot of interview questions from the mega companies. And I'm not going to quickly go over the definitions. We'll go pretty in depth so that hopefully you will have a solid understanding of what these type of data structures really are. After providing the definition to you guys, we'll work through some of the practice problems together so that we get a feel of how things work. I recommend you have an editor ready so that you can code along with me as I explain the problem to you and solve it together. We'll try to solve the same problem in various ways, such as using a recursion in the first step, as well as erasing the code and going back and trying to solve it using loops. So hopefully, as I give you guys a lot of different ways to solve the problems, it'll help you think these problems in a variety of ways, in a more flexible ways. And one thing to keep in mind is that data structures is not so much about memorizing the solution all the time, is to have all the tool set, have all the different ways that this could potentially be solved in your brain so that when interview questions or when some complex problems occurs in your day-to-day job, you have the tool set you need to tackle those problems instead of just memorizing every solution. Because honestly, you can't memorize every single solution, nor is it even the recommended approach. After working through some problems together, I'll then give some additional practice problems that you can try solving on your own. And this is really important that you try to do these problems on your own. Like they say, you'll never become an NBA player just by watching a lot of NBA. You have to put in the work daily in the gym. And just like that, if you want to become a professional developer, you need to put in the practice instead of watching these type of videos all day long. I'll be posting a follow-up video showing some of the solutions so that you guys could follow along and verify the solution that you came up with as well as compare with mine. Or if you're just absolutely stuck, you could see how I solve it and try it again on your own. But I really encourage, and this is very important, I really encourage you to try to solve it on your own first before watching the solutions. Let's talk about some of the prerequisites that this course has. There isn't a lot, to be honest, which is a good thing, but there are a few, so let's quickly go over them right now. So first of all, I'm going to assume that you know the basics of JavaScript. You should be able to know how to formulate functions, know what an array is, know the various loops you can do, as well as some programming topics such as what a recursion is. If you don't know how to do these topics, I think you should try watching this series later and get a good grasp of what JavaScript and what basic programming is first. There's a lot of free courses available online and especially on YouTube that you can check out. And I may also make a full-blown courses for those type of topics later. So let me know in the comment section below if you're interested in that from me. And a topic in particular that you should know a bit more are JavaScript classes. Here are examples of the human class below. You should know what fields are, such as the name and the age fields you see below. You should also know what a constructor of a class is and what it does. and how to instantiate a new instance of the class, as I'm doing below, with person 1 and person 2. And this is the extent of classes that you should know. I'm intentionally going to try to avoid some of the more complicated class topics in this series so that we don't have to get so caught up in the details. And another prerequisite, again, is to have the determination to really learn. Pause the video time to time, try to solve it on your own, and then continue watching the video. This is really the only way to learn. All right, so let's get started with the definition. Before we can learn what a singly linked list is, we have to understand what a linked list is. Remember that a linked list is a broader category that contains a singly linked list as an example. So first of all, what is a linked list? Here is a definition that I pulled from Wikipedia. A linked list is a linear collection of data elements whose order is not given by their physical placement in memory. So there's a lot of jargon there, so let's try to break it down piece by piece. First of all, it's a collection of data. In my diagram, you'll see that this list contains the elements 4, -5, 0, and 16. Some examples in JavaScript of a collection of data are things such as an array or an object. But it's also a linear collection of data. The word linear means that it's one-dimensional. Arrays are also one-dimensional. Something that isn't linear are things such as tables, which is two-dimensional. It also says that it's a linear collection of elements whose order is not given by their physical placement in memory. The memory part is essentially what distinguishes a linked list from an array. We say that an array stores elements in contiguous memory locations, meaning that one element is in memory right next to the adjacent elements. This is not the case in linked lists. Each element can be stored in any part of the memory. So if you look at my example and pretend that the spacing is the actual location in memory, my diagram is not really an accurate representation of a linked list, but it's actually what an array might look like in memory, excluding the arrows. Arrows are like a linked list thing. Now, this is what it actually might look like in memory, where each element can be located anywhere. And even though the element 0 might be located after -5, it can be placed before -5 in memory. So this is unlike arrays, and this distinction makes some interesting trade-offs of the performance of common operations between a linked list and arrays. But we'll take a look at that after we get a feel of how linked list actually works later in the video. But outside of this distinction, for now, you can pretty much think of linked lists as a more complicated version of an array. It's like an array in that it holds a linear collection of data. Here are examples of the same list represented in an array for both JavaScript and TypeScript. There's also several different variations of a linked list. We'll be covering singly linked lists today, but we'll probably cover some of the other ones in future videos. And here's an important definition you need to know about linked lists. Each element of a linked list are called what's called a node. So in my example, the little box that houses 4, -5, 0, and 16 are all instances of a node. Now let's talk about a node in more detail. So again, a node consists of a value and one or more pointers, aka reference, that can point to another node instance. So looking at the first node as an example, here we have a node 1 whose value is 4, and it's a node that has a reference to another node whose value is -5. That's node 2. We'll just call that node 2 for now. And one important note is that it doesn't necessarily have to point to another node. Look at a node with value 16. It isn't pointing to any other node, and this is fine. You can think of 16 as the last element of an array, which is an element without a following element. Also, I specifically pointed out that a node can have more than one pointers. The example I provided here with just one pointer is a singly linked list. Other types of linked lists can have 2 pointers, for example. In a doubly linked list, the node -5, the middle one, would have an additional pointer that points back to 4, in addition to the pointer that points to 0. So that's what makes a doubly linked list, but we won't cover that today. We'll just be focusing on a singly linked list today and go very in-depth with what this is. And as I said before, it contains one reference that can point to another node. We usually name this next. Let's now hop onto our editors and create a class that can represent these nodes in a singly linked list. All right, so I have my editor open right now, and as you can see, it's split in 2 columns. On my left, I will be writing the JavaScript version, and on the right, after I'm done with the JavaScript version, I will copy and paste the JavaScript version over so that we could just add types to it. So we are going to be defining the class of a list node. So specifically, as we discussed, we're going to be defining the node that we talked about. Now, we could define this many ways. There's no strict, one way to define this. We're also going to be using classes because if you study linked lists in other courses, they usually always teach it in classes. So we could technically use an object, a JavaScript object, to represent these, but for the sake of consistency of other courses and other how people usually teach linked lists, we'll be using classes. So let's start out by calling this. We could call this whatever we want. Remember, we're going to define a node of a linked list. So let's just call it a list node. So list node. Specifically, this is going to be a singly linked list node, but that's just too wordy. And because we're only focusing on singly linked lists anyways, we'll just call it a list node. It's going to have two properties, as I stated before. First one is the value, which is the number. And the next field is going to be called next. And this is the reference to another node that you can potentially point to. Let's define a constructor now. Constructor, and we will take our first argument as the value that you want to put in this, for example, -4 or whatever. And just to make our life easier, you don't have to do this. Let's just, if they don't provide a value, we'll just default it to 0. So if they created a new list node instance without any arguments as a first parameter, we will just default the value to be 0. This will just make our lives easier. And the second argument is another optional argument, which we will call next. And this is the next node that it wants to point to. So we will default this to be null. And when the next value is null, that is essentially saying that this node does not point to anywhere. Like, I believe it was 16 in my example. I could be wrong, but the last element of the list will always have next equals to null. So we just now have to apply these arguments to our field. So this dot value is going to be the value that was provided. And then this dot next is going to be the next that was provided. So let's just quickly come over here and give the TypeScript definitions of these. So value is going to be number. And next is going to be another instance of a list node, or it could also be null for the last element. Here, we don't have to type because it's inferring the type I to 0 here. And here, we should type it because it could be a list node or null. Let me kind of put some spacing here so that it's prettier. There we go. So let's go back to our JavaScript definition. Let's make a couple instances of a list node just so that we know what this is about. So const node1 is going to be a new list node with the value being, let's see, 4. And next is going to be null for now. And let's make the next node, which we'll call node2, be a new list node of value -5, and it will also be null. Const node3, new list node of 0, null, and const node4 of new list node of value 16 and null. So as we have created these right now, none of these nodes are pointing anywhere. So these are all like a node that doesn't point anywhere. So they're all kind of like isolated from each other. And let's just see that we did this right. I'm going to put console log of some of the values. So what should node1.value give? It should give 4. Let's just see that we did this right. I'm going to run it, and it gives me 4. Hopefully you guys can see this. I'm not going to try to do it for all these other ones because that's just a big waste of time. And also, if you're following this in TypeScript, you could also just do the same thing here. There's no difference. These are all typed correctly, so that's good. Now let's actually make it all linked with each other. So in my example, I had the node whose value was 4 was pointing to node 2. So the way that we're going to do that now is node 1, his next value is going to be node 2. And node 2's next value is going to point to 0. Not 0, whoops. It's going to be node 3. And node 3's next is going to point to node 4. Let's try to do that in TypeScript real quick. Node 1, and here's a good thing about TypeScript. Do you remember? Oh, look, it already tells me there's an error. I don't think JavaScript would have told me that. And here's a good thing that I want to mention about, remember what I put here for JavaScript? I put 0 here. But TypeScript gave us an error, so we know that something's wrong, and it should have been node 3. So if you're not using TypeScript, I highly encourage you should learn it. It's very useful. Not next 4, node 4. There we go. So this is a definition of a list node. All right, now that we defined what a list node is, where does a singly linked list come into play? Before I answer that question, let's do a bit of a cleanup. Here we put nulls for every single reference, every single next value. Instead of doing that, let's just put whatever we did here in here. So the only way we could do that is let's put these in the opposite order, like so. So node 4, node 3, node 2, node 1, and node 4 will point to nothing. Node 3 will point to node 4. Node 2 will point to node 3. And node 1 will point to node 2. So let me erase this. And then we'll do the same thing here. I'll just copy this and paste this over here. There we go. All right, so going back to the question, now that we define what nodes are, how does a singly linked list come into play? Well, essentially, these are all versions, instances of a singly linked list. So for example, let's take a look at node 1. Remember console log dot, let me kind of put more spacing around the JavaScript area. If you're following with TypeScript, just do the same thing I'm doing in TypeScript. Load node 1, let me write node 1 value is node 1 dot value, right? We already saw what that was, and that's going to give us 4. Now, let me show you why this is an example of a singly linked list. Check this out. Next node value, and we will do node 1. How do we go get the next node? It's next property, and the next property is an instance of a list node, which has the property value. Let's try that. That should give us -5, right? So let's try that out. Node 1 value is 4, as we know. The next node value is -5. So as you can see, they are already connected right now. So for example, to be more explicit, we could say const singly linked list with 4 values, with 4 elements is just node 1, because that one has node 1 next is node 2, and node 2's next is node 3, and node 3's next is node 4. Let's just make sure that that is correct. I'm going to console log this crazy expression here. Let's see if that gives us 16. Right click, run, and 16. Look at that. So a singly linked list with 4 elements is node 1. Const a singly linked list with 3 elements is just node 2. Because node 2's next is 3, 0 with element value 0. And his next is node 4 with element 16. Const singly linked list with 2 elements is node 3. And const singly linked list with 1 element is just node 4, because node 4's next is 0. Now, how do we make a singly linked list with no element? Well, we were calling nulls as a no pointer. So why don't we just define it as a singly linked list with 0 element is just going to be null, like that. So there's other ways to represent singly linked lists. In other courses, they might create a new class, like a singly linked list that houses these nodes as elements, but it's really not necessary. You could do that, but this, I feel that is enough. Hopefully this makes sense. And we will continue on with this type of definition. All right, so now we have a data definition of a list node that also works like a singly linked list. It's like the same thing. But we can't really do anything with these. Remember I said that singly linked lists are, you could think of them as like an array, but array has a lot of helpers, such as you could grab a specific element of an array by passing in the index. But you can't do that right now with the definition that I have currently. There's also other things that you can do, such as pushing a new element to the array or popping an element out. Those are things that you currently can't do. So let's make functions that can essentially give us those behaviors from this list node. So I wrote a couple questions and we're going to be going over them together. I will walk you through how to solve these questions. Let me show you guys the question first. So here is a question that I have. We're going to be going through how to solve these questions together by making these functions. And then I'm going to give you guys some additional questions that you guys could do on your own. And in a follow-up video, I will provide solutions. But again, try to do the follow-up on your own instead of looking at my video solution first. But these ones, we will try to go through it together, although it might be a good exercise to try to make these functions on your own first by pausing the video now. All right, let me just copy these over to my editor, and I'll be doing this in JavaScript and adding the TypeScript comments types after. Let me just erase these. These are just explanations. We don't need them right now. Let me make a code question comment here. So let's first start with the first one. And just so that we have more space, let me do this. All right, so here is question number one. I'm zoomed in too much, so I need a couple lines to do this. So create a function called toArray that takes in a singly linked list, which is same thing as list node in the way that we defined it, and returns an array representation of the data. So for example, if we did toArray, what's the empty version of a list that we defined earlier? It was just null, right? So if we do toArray null, that should just give us this. If we do toArray of a singly linked list, let's just pretend an array for now is a singly linked list of this, then that should give us 4. And if we do toArray of like 4, -5, that should give us the array version of 4, -5, like so. So let's try to do that. Let's call this toArray as the question states. And we are going to be taking a linked list. So we'll just call it SLL. And it returns an array. So let's take care of our base case first. Remember, an empty singly linked list is just null. So if SSL is equal to null, what do we return? What's an empty version of an array? We just return an empty array. Now that we have taken care of the base case, there's multiple ways to solve this. I will be showing you guys 2 different solutions. First, I'm going to be using what's called a recursion. And then after the recursion, we will be using a for loop, or I don't think we're using a for loop, some other loop, I believe a while loop to solve this. So let's first solve this using recursion. All right, so we know that this is a list node. So if we do SLL of value, whatever we pass in, that will give us the element. So because we need to return an array of values, to use recursion, we're going to call this function itself within here. So let's do this. How do we get the value of the current location that we're in? We do SLL.value, and we want to return an array that contains this and what? We are going to concat this. Concat is an array. How do you spell this? Concat. Concat is an array method that adds this array to whatever other array that we put here. So for example, let me just comment this out. Ignore this for now. And let's try console log 1, 2, concat 4, 5, 6. That will give us 1, 2, 4, 5, 6. Let's run it just to make sure we're correct. Yep, 1, 2, 4, 5, 6. So we're going to be using this. So we're going to do the current value concat with, we're going to use recursion. So call to array again of, now that we have already passed in, got the current value, we are going to pass in the next list node, which is another instance of a list node that may contain more list nodes. So this is the recursive solution to this. And let's see if it works. So for example, here is node 1. That should give us 4, -5, 0, and 16, right? Let's try that. Console log to array of, what do we call it? Node 1. Yep, 4, -5, 0, 16. What about the base case? Does that work? It should. It gives us an empty array. That's very good. And what about maybe like node 3, which has just 0 and 16? Yep, 0 and 16. Okay, before we continue, by the way, I also said this is a recursive solution. I will give you guys the loop addition version of this. But before we do that, let us paste this to our TypeScript file. To array singly linked list is a list node or null. And this will return an array of number values. So we will do this. So if this is null, return this, otherwise concat. And now we have typed this correctly. All right, so this was the, as I said, the recursive solution. Let's do the loop solution. Whoops, what happened here? Const to array, again, it takes in SLL. I kind of regret calling this SLL. Let's just call this a link, a list node for now. Doesn't matter. I don't like SLL because it's just too much abbreviations. All right, so if list node, should we do this? Let's do this. Let's define the output first, and we will start pushing each element, if they exist, to the output. We will call this the output variable, and we will instantiate it with an empty array. And as this list node contains values, we're just going to be pushing it to that. Now, there is this concept called a runner in a singly linked list and all linked lists in general. A runner is basically a pointer that points to a certain part on the node. So for example, it might first start out by pointing to this one, and then it points to this one, and then it points to this one, and then it points to this one, and so on. We call that runner because it's kind of running through the list. So let's define that runner, and we're gonna use let because the runner can change. And we will start out with the first element in the list, which is list node. And let's do a while loop. While there is a value, while the runner has a value. So right now it's pointing to the first element. While it has a value, we're gonna do something. We are gonna push this value to the output. So output.push runner.value. And then now that we have already pushed this value, the current location is kind of useless to us now. So let's set the runner to the next element in this list. And the way that we do that is runner.next. So this will make runner be the next element in the list, and it will go back to this for loop. As it has a value, it will give it a value and give it next. What happens when we get to the end? When we get to the end, next value is null. So here, this will become null. And while null doesn't have a value, right? So this will actually result in an error. So what we should do is we should say while runner exists and runner, this is actually bad. This is actually very bad because runner.value will give us the elements here, right? 0, if we ever got here, if we put 0 here, because 0 is a falsy value, this will break out. This will become false and the while loop will no longer run. But we don't want that to happen, right? So I'm sorry, the runner.value was a very bad way of doing this. We should have done it like this. While runner is not equal to null. So again, while runner is not equal to null, push its value, because if it's not null, we know for sure that the runner is a list node and it must have a value, and set the runner to the next element in the list node. And keep on doing that until it becomes null. So after we have done that, we should return not the runner, but the output, which was an array that we have hopefully populated here. Let me copy this. Actually, let's test it first. So let's try console log to array of node 1. That should give us everything. Let's see if it does. Yep, 450 negative 16. Let's try null here. And it gives us an empty array. So this concept of a runner, which is a pointer to point to a specific element in the list node, is a very important concept. And we will be using this type of a method commonly in the questions that we solve. So let me just give you guys the TypeScript counterpart. I'll just call this toArray using loops. And list node is going to be a list node or null. And the output is an array, like so. Not an array, it's an array of numbers. Oh, that's bad. Okay, whatever. We're running out of space, but it's okay. And output is a type of number array. And that runner can be a list node or null. So while runner is not null, push a runner next. That should work. And if you look at Dex here, it's an instance of a list node. So it should have said null too, but whatever. Okay, so that is the TypeScript definition. That was the first question. Now let's grab the second question, which is this one. And this one is very simple to do because we're going to be using the first solution. Whoops. Create a function called console log. Let me give more space to the JavaScript that takes in a singly linked list and console logs the array representation of the linked list. So this is super simple. Const console log. We're going to take in a linked list. I'm using a different name every single time. That's probably going to be confusing to you guys. So I'll just call it a list node and stick with that name for now on. And we're just going to console log the toArray output of list node. Let's see if that works. Console log of node 1. Let's try node 2 this time. That should give us an element with 3 elements. And it does. And this one, the TypeScript version, is very simple as well. List node is a list node or null. And the output of this function is void because we're not returning anything. And it doesn't matter. We don't need to use this one. We'll just use this one. All right, so what is the third question? Let's get rid of the console log call and put the third question here. All right, so create a function called size that takes in a singly linked list and returns the number of list node that the list contains. So again, we could solve this using recursion, and we could solve this using a loop. And the method, as you might hopefully see, will be very similar to the way that we have solved the two-array one. So let's start. Const size takes in a list node and returns a number of list nodes that the list contains. So we're going to be using recursion in the beginning. So the way that we're going to do that is, let's first check. In recursion, you always need a base case. The base case is if list node is null, right? So if list node is null, what is the size of a linked list if its first element is just null? Well, its size is 0. It's the same thing as an empty list. So let's just do return 0. Now that we have taken care of the base case, we gotta create a function that calls this size function itself, which is called recursion, right? So let's do, since we have taken care of the null case, we know that it contains at least one element, right? So let's do return 1 plus, and we're gonna recursively call size again on list node.next. So this will make it so that we will keep on adding 1 every single time until we go to null, then we just add 0, which won't add anything, and this will give us the size. Let's see if it works. Console log size of node 1 should be 4. And let's just take care of the element empty case 2. Size of null should be empty. Let's see if this works. Yep, 4 and 0. Let's copy this over here. Size takes in a list node, which is a list node or null, and the output is a number. And that is it. I'm just gonna keep these examples for now, comment out the recursive solution to this. We're gonna be making a new solution using for loops and the concept of a runner. Const size is list node. And do we need to take care of the base case? Did we use the base case scenario here? We did not. And we're gonna be doing the same thing here. Let's say that the output is 0, kind of like how we started out with an empty array. We're gonna use the base case, which is 0. And we're gonna define the runner to be list node, the first element of this list. And then, just like the loop and solution we did for the two-array function, we're gonna do while runner is not equal to null. Output, we're gonna add it by 1, because that means we know there's at least one element there. And then we're gonna say runner is runner.next. So we're gonna have the runner run through each element in the linked list until it gets to null, meaning the next value is null. And then we stop, and then we return the output. And let's make sure that this function works with these two examples I have given here. Should give us 4 and 0. It does. And just to make sure that I'm not tripping, and it is working, node 2 should give us 3. Yep. Let's bring this over to TypeScript to give you guys the TypeScript version. And we'll just call this size using loops. List node is a list node or null, and the output of this is going to be a number. So let output be 0. We don't have to type this because it's inferred. You can type it if you want, but sometimes I find it cleaner that for TypeScript to infer the type. Runner, we need to type because it could also be null. So while runner is not next, output +1, runner is runner next, return output, and that works. Now, this is the final question that we're gonna be doing together. If I could just find it. I'm not used to being zoomed in this much, so sorry if I'm being a little clunky. I'm zoomed in this way so that you guys can see my screen. All right, create a function called push that takes in a singly linked list as well as a list node and adds the list node to the end of the singly linked list. Oh, now this is where I regret telling you guys that we're going to be using this. Doesn't matter actually. Okay, so all right, I'm going to make some modifications to this function, the requirements, and we're just going to have the function output the result of the push. So this is a little bit different than the arrays push method. And let me explain what I mean by that. And by the way, I actually didn't know this about pushes. So what is console log of the result of pushing to an array? Let's push like 8 to this. So what do you guys think that what will be console logged when we do this? So if we try it, it gives you 2. Now, why the hell did it give us 2? Let's try this again. Console log of an empty array. And let's push like -500. This will give us 1. But why does it give us 1? So I actually didn't know this. And I actually paused the video to look this up. I learned something interesting. The push method adds one or more elements to the end of an array, but also returns the new length of an array. So that's very interesting. In my programming life, I never had to actually use that, but I guess that's a good info to learn. But that's not what we want to do here. Instead, we want our push version return the result. So for example, this should return in our example 1,8. And this should return to us just -500 list node. So let's try that. What do we call this push? Let's take our first argument, just call it a list. And let's call our second argument the list node that we want to push, that we want to add. And we are again going to solve this using the base case and also not a base case, using a recursive solution and then using a while loop. So let's try with recursion first. With recursion, you always have to have a base case first. So if list is null, then what do we want to do? If it's null, we just want to return the list node. Now that we have taken care of the base case, how should we do this so that we can push to the end? So let's do this. Return. What do we want to return? List. Let me think about this real quick. Let's do this. We are going to return the list. Before we return, let's do this. List.next is going to be the push version. We're going to recursively call this push of list.next. Now, and this push function takes in a second argument. We're just going to pass along this list node parameter that we got. So what the heck is going on here? So let's think about this, right? Let's use our example of, let's just start out with a simple example of an empty list. Pretend that this array is a linked list. So we are passing in to push this empty list, and we are passing in the linked list node of 5. So what is happening here in this example? If list is null, is this null? Yeah, so I guess it's better to call it null. Yes, it is null. Then we're just going to return the linked list equivalent of 5, like so. Now, what if we did push of 1 and then 4? How should this look like? All right, so is list null in this scenario? No, it's not. So we ignore this case. Then this guy's, his next, which right now is what? Is null, right? Because he doesn't have a next right now. So his next was null, but it's gonna be the result of push of what is list.next. It was null. And we just pass along the 4 in this case. right? So what is the result of this? Is list null? Yes, then we return this, the return of this. Let me put that in the next line. Push of null 4 is just gonna give us the list version of 4. So this is essentially the same thing as this. So 1.next becomes this guy, right? And that's why this works. But we don't want to just end it there. We want it to return the list that return the original list, because we want the output to return this. Now, as I'm writing this, I'm also explaining at the same time, so I don't fully know if this works. Let's see if this works or not, right? So what should, let's see, let's take our node 1 here. Remember node 1, I'm just gonna write it here just so that we know what it was. Let's actually console log node 1 using the method that we created. Yep, 4 -5 0 16. Now let's console log the push of node 1 to a new what do we call it? Node list node of what value do we want there? 100, and it won't have a next. So let's see what that is. And actually, that's super confusing, right? So we want to actually console log, not console.log, but we want to console our console log of this. And it works. So it pushes it, and then it returns the final list. I feel like I didn't give enough examples. Let's try the example of 1, 2, and 3. And we are passing in 4. Let's try this example and see what happens. Actually, I think 2 is enough. So let's try this example. So we will start out first with the list. Is the list null? No, it's not. So his next, which was 2, is gonna be one's next is gonna be the result of push of this guy, because that's list.next, and we just pass along the 3, right? So what is the value of this? Push to 3 is going to be, is 2 null? No, it's not. So his next is going to be what? Push of null, because 2 doesn't have a next, right? And we're just going to pass along the 3 list node. Now, what is push of null 3? Push of null 3, it is null, so we just return the list node. So we just return the 3 as a list node. So the result of this is 3, right? It's a 3 linked list. And the result of this, what was I? Is going to be 2 and 3. So this becomes 2 and 3. So one's next is 2, 3, 3. So this ultimately is 1, 2, and 3. And that's why this works. Recursion is a very hard thing to grasp, even for me too. So I highly recommend you try to put console log somewhere and try to understand how this works. If you understand it, then that's great. Now that we have solved the recursive solution, let's try to use a loop solution. Bam, bam. Bam, bam. Oh, and before we get to the loop solution, let's actually get the TypeScript version of this, right? Const push list is a list node or null. List node is a list node or null, and the output of this is never gonna be null, right? It's just gonna be a list node, because if you're pushing an element to an array, it's not gonna end up empty. So that's it. Now let's do, and by the way, I think I was too fast there. Here it is. You could pause the video and try to write this if you're following along in TypeScript. All right, now let's get the loop version of push, list, and list node. As always, should we use an array? We don't want to use an array here. And for the practice problems that I'm going to give you at the end of this video, please don't use arrays to try to solve this. Try to do this without using arrays or like objects or things like that. Let's see, how can we do this? So let's use the runner. It's going to be the first element on the list. And while, let's see, while, let's see, how much do we not want to go this? Let's do it like this. While runner.next is not null, meaning let's have the runner run until its current position's next doesn't exist, meaning it's the last element on this list, right? Then we want to do this. While it's not the last element, let's have runner be runner.next. Keep on running until you get to a situation where its next value doesn't exist, aka it's the last element in the list. And once that is done, we are out of the while loop, and then we can just do runner.next is no longer going to be null, but it's just going to be list node. And let's return the list. Let's see if this works. By the way, there's a bug in here because, let me show you guys the bug. Actually, before I show you guys the bug, let me just verify that this works for the non-edge cases. Let's try our version of console log of node 1, which has the 4 elements like this. And we want to push new list node of 101 this time. Let's see if that works. Oh, and what am I doing? These should be wrapped in our push call. Like so. Yep, and it works. Now, what bug am I talking about? What if the list was initially empty, then it should create a new list node with 101. Let's see what happens here. And there is a bug. Because if this was null, then runner.next doesn't exist because you can't do null.next, right? So we have to take care of the base case here still. So if list is null, then let's just return list node like so. Let's see now if this no longer results in error, and it doesn't. So this is the solution. Let me copy this over to the TypeScript. We will call this push using loops. List is a list node or null. List node has to be a list node, and the result of this has to be a list node. Did I do that here too? All right, this shouldn't be a null. Let me erase that. That was the original push function that we made. And let runner be a list node or null, and we are done. All right, so those are the 3 questions. Was it 4? Yeah, the 4 questions that I gave you guys initially. And before we go on, I just want to show you guys my GitHub account. This repo right here is called Data Structures and Algorithms. It will contain all the solutions that we've gone over, as well as the data definitions, as well as the practice problems that I'm going to give you guys soon, and the solutions, which will be posted later. Right now, it's still a work in progress, but as you can see, I have created a folder called singly linked list. You come in here, go to definitions. You can see the definitions for both the JavaScript version and the TypeScript version. And the tutorial that we just went over, you can see the questions here, the solutions in TypeScript, and the solutions in JavaScript. So I will post a link to this repo in the comment description section below. So please use this and refer to this page. I'll be updating it with the solutions and the homework questions. I'm not sure what I'm going to call them right now, but the practice problems I'm going to be giving you at the end of this video. Now that we got a feel for how singly linked lists work, let's compare the performance of a singly linked list and JavaScript arrays. But before comparing the performance, I have to briefly explain what type of arrays JavaScript uses. JavaScript's arrays are what's called dynamic arrays, unlike static arrays that you might find in languages like C++. This means that you don't need to declare the size of the array when you first declare a new array. Arrays in JavaScript can grow and shrink. The reason why arrays traditionally needed to know its size is that since arrays store elements in a contiguous location in memory, the compiler needed to know the amount of memory it needed to reserve for the array. But in dynamic arrays, like JavaScript, there's some magic that happens where it first allocates some additional space for the newly created array and grows and shrinks as it is needed. We won't go too in detail about here how that exactly works. Now, here's a table I found on Wikipedia on the performance between a linked list and dynamic arrays. It's only row 1 and 3 that we are interested in. To peek, aka grab a particular element given an index, it takes O to the n for a linked list, and it is instant for dynamic arrays. So for peeking, dynamic arrays are the clear winner. By the way, in the practice problems I'm going to give you, you will be implementing some of these methods. Now, to insert or remove a new element to the beginning of the list, it takes dynamic arrays O to the n, whereas it is immediate for a linked list. To insert or remove at the end of the list, it takes O to the n for singly linked lists. Ignore the O to the 1 that you see there, because that is actually for doubly linked list. So for singly linked lists, it takes O to the n to insert or remove at the end. The doubly linked list we'll cover in another video. For dynamic arrays, it is usually O to the 1. I say usually because the only times when it isn't O to the 1 is when the compiler didn't reserve enough space for an additional element. So he has to move all the elements to a new place in memory. In that case, it will be O to the n. But JavaScript is smart enough to make this be O to the 1 for most of the time. And for inserting an element in the middle, it is essentially going to be O to the n for both, although it is slightly faster for linked lists. All right, so now I think you guys should be well prepared to tackle any type of problems that they may throw at you that's related to singly linked list. I'm back at my repo right now. Again, here's a link, but the link will also be shown in the description of this video below. So go to this link, go into singly linked lists, and you should see this additional problems here. So these are the challenge problems that I highly recommend you guys do. So let's check it out. We go in here. Right now, there's only questions, and this is what you should be looking at. In the feature, if you're watching this video in a feature date, there might be solutions directory here. Please don't look at that until you've tried solving these questions on your own. So there are 6 questions here. These should be, they may sound confusing, but they should be pretty straightforward if you are comfortable with arrays, because a lot of these are similar to some of the common array methods that you'll see, such as create a function called @ that takes in a singly linked list and an index and returns the list node at that index. So for example, @list node at index 0 will give you this guy. Pretend this is a linked list. And at 3, it will give you this guy, and so on. Insert at beginning is you just get a number and insert that as a list node at the very beginning of the list. Fairly straightforward. Insert the index, similar, but you could insert some element at a certain index. So for example, here, if you want to insert 100 at 1, you put it in between here. So that kind of makes it look like this, and on and on. So some of these will be very challenging, but again, I highly recommend you try it. You might be banging your head for a little bit, as I did when I first encountered these, but I promise you it'll be good practice. And stay tuned. If you want the solutions, and my solution video is not out yet, please subscribe to my channel and let me know, and I will try to get it out as soon as possible. So this concludes our session in singly linked list. This was part 1 of my data structures and algorithms course. There will be a lot of other topics covered in this series. So probably the next one will be on doubly linked lists. So again, if you like this content, please subscribe and like. the video to let me know that you guys like this type of stuff. And if you guys have any advice or any areas where I can improve, please let me know in the comment section below. And also, as you guys are working out the practice problems, which you should be doing, if you get stuck on anything, please try to post a comment below on this video, and either myself or someone else can help you out. So anyways, stay tuned for the solutions to the homework problems that I gave you guys. And also stay tuned to the doubly linked list video that will come soon. I also have a LeetCode question, the second question on LeetCode that I'm going to solve soon after this. That also uses singly linked lists, so please stay tuned for that. And guys, good luck with the homework questions and have a good one.